welcome to my channel. This is Leo and let's do some more Leetcode problems today. Today's problem is called maximum points you can obtain from cards. There are several cards arranged in a row and each card has associated number of points. The points are given in an integer array card points. Okay, so it's given here. And in one step, you can take one card from the beginning or from the end of the row. You have to take exactly k cards. Your score is the sum of the points of the card you've taken. And given the integer array and the k, return the maximum score you can obtain. Okay, so this is very interesting. We can take one card for each time, either from the beginning or from the end. And we can only take k times. So we have to compare which one is larger to maximize our results. Okay, so here 1 and 1 is equal, so we can take either. Let's take this one first, and then we compare 2 versus 1. Of course we have to take 2, and then 3 versus 1, of course 3. So the maximum we can take in this way is 6. Okay, and let's try another one. Let's take this one first. Then we have to compare the 6 with the first one. We take 6, and then 5 versus 1, we take 5. Okay, so either we're taking k elements from the front, or we take k elements from the rear. Okay, or there's other possibilities, like we can take 1 from here and the rest 2 from here. Okay, or either we can take 2 from here, 1 from here. Okay, so all in all, we have to take consecutive numbers, a number of consecutive elements from the front or the rear. Okay, so to solve this problem, I think it's better to keep the prefix sum of the first k elements and the prefix sum of the last k elements, so that we can have a comparison and we choose the optimal number from each step. Okay, so let's try it. First we have to record the card points length, okay, and then we can initialize 2 arrays, like front, to store the prefix sum of the first k elements. Let's initialize it to k plus 1, and also from the rear, k plus 1, okay? And let's start iterating. So front I plus 1 will equal to card point I plus front I. Okay, so that we can save it here in the array. And also it works for the rear. It will equal to card points. This will be n minus 1 minus I, because we have to take it from the back. Okay, and it should plus rear I. Okay, in that case we can initialize a max number. This will be returned at the end, so we will iterate through the k elements to see which 2 elements will give us the best result. Okay, so I equals to 0, I is less than or equal to k, I plus plus. So the current would be front I plus rear k minus I. Okay, and we will update the max along the way. So now we know what the max is. Okay, so that's pretty simple. Let's take a look. Okay, it passes the tests. Let's analyze the complexity here. Okay, so the time complexity, we have 2 scans, so that's going to be k, and for the space we have 2 arrays created, so that's k. Okay, I think it passes the tests. And there's another question: can we further optimize this? Because for DP and especially for this one, I don't think we need the whole k array. Okay, so maybe we can do something like this. We can use 2 variables to record it. Okay, so let's say front score equals to 0 and rear score equals to 0. Okay, and we don't have to do this. Okay, we just have to save the perfect sum into the front score. Okay, so front score plus and equals card points I. Okay, and we still have this max score, but this time we will set it to front score, so that if there's anything that's larger than this max, we can update it. Okay, so still here, but this time we will start from the beginning and the k minus 1. Okay, so from here, and I is larger than or equal to 0. Okay, we'll start from the back. So now we have something from the rear. Okay, let's update it. Okay, let's keep it as it is. So rear score will be card points I. Okay. Oh wait, it shouldn't be like this. Rear score is from the end. From the end of it. So it should be n minus k minus I. Right? And the front score will take that out. Card points I. Okay. So now we have the front score and the rear score, and our current maximum score will be the sum of these 2. Okay. And we will still compare it with the current max. So in this case, we saved, we optimized some space for it, and the space should be a 1. Okay, let's see if it still works. Okay, looks like so. So let's submit it. Perfect. So the memory here is less. Okay, so that's this problem. It's pretty easy, but I think it requires some thinking and some familiarity with dynamic programming. Okay, thank you so much for watching. Hope you like the video. If you like it, please like and subscribe to my channel. I'll see you in our next video.